Hydrocarbon derivatives. We've already touched on hydrocarbons. These were compounds containing just hydrogen and carbon atoms. And we've looked at alkanes, alkenes, alkynes, cyclic hydrocarbons, and basic aromatics. Hydrocarbon derivatives are compounds that contain another atom, and it's usually oxygen or nitrogen or both. So functional groups. Functional groups are a group of atoms that is responsible for the chemical and physical properties of the hydrocarbons and the hydrocarbon derivatives. They are consistent within a classification of type of hydrocarbon or hydrocarbon derivative and can be used to identify or name them. So if you see the same cluster of atoms, you'll be able to recognize which hydrocarbon group or hydrocarbon derivative group that they belong to. And in class we have a note called classes of organic compounds that goes along with this. And if you search for classes of organic compounds online, you will also find these outlined for you. So you might not think of alkanes as having a functional group, but basically if your hydrocarbon has each carbon bonded to 4 different atoms, it is an alkane. An alkene, on the other hand, must include at least 1 double bond. An alkyne, the tell for an alkyne is a triple bond. A cyclic hydrocarbon, of course, has some sort of a ring structure in it, perhaps using line diagrams. And an aromatic will always contain benzene, at least 1 benzene, and that could be written the new way or the older way, where it looks like it's got alternating single and double bonds. So in terms of hydrocarbon derivatives, we can have haloalkanes. Halo means halogen. So these are your halogens attached to a carbon. So perhaps you've got a chlorine. And the names, basically you take off the INE and you add an O. So chloro, bromo, fluoro, iodo. An alcohol, its functional group is a hydroxy group. So an OH group is added. Sometimes it's written just as an OH, sometimes it's an O with a bond to an H. There is a bond between the O and the H, you just don't have to show it. So these are alcohols, and the ending for all alcohol names is OL, from the OL at the end of alcohol. We also have aldehydes. Aldehydes have something called a carbonyl group. That's a carbonyl group. It's a C double bonded to O. And they also have, specifically for aldehydes, an H on the same carbon. So this carbon is always on the end of the carbon chain. And all aldehydes end in al. So butanal, methanal, and that comes from the al at the beginning of aldehyde. A ketone also contains a carbonyl group, but it is not found on an end carbon. It's always in the middle of a chain somewhere. By middle, I don't mean exact middle, just not on an end carbon. Sometimes we represent these with R's. So we have an R and an R prime, meaning there's 2 different chain lengths on either side. And that R stands for some carbon chain length. And the ending for all ketones is ONE, so butanone, pentanone. And of course, the ending comes from the term ketone. Carboxylic acids. So a carboxylic acid contains a carboxyl group, which is a carbonyl group and a hydroxyl group. So this is called a carboxyl group. And again, like aldehydes, these are on end carbons or terminal carbons. And to name them, basically we take off the ANE and we put in oic acid, butanoic acid, pentanoic acid. Esters. Esters will have a carbonyl group attached to some carbon chain, and then it will be linked to another carbon chain through an oxygen. So this is called an ester linkage, and to name esters, the suffix or the ending becomes O8. And we'll get into more naming of these when we look at these individually. So this is a tel. This is the tel for having an ester, the functional group. Ethers are basically two carbon chains that are connected by an oxygen. So these are called ethers. So if you don't have a carbonyl group, you just have a COC, and of course those are basically R groups. There's different chain lengths on either side, and we call these, the suffix for these is oxy followed by an alkane name. So we'll get into naming again, but you'll see the name oxy and an alkane. So methoxy, ethane, ethoxy, propane, but you'll have a root followed by an oxy, and then another alkane name. Amines. Amines contain a nitrogen. So you could have some R group, some carbon chain, and one possible example is a nitrogen with two hydrogens. You can replace each one of these bonds with some length of a carbon chain. So you could have 3 carbon chains coming off, or you could have 2, 1 hydrogen, or you can have 1, like here, 1 carbon chain and 2 hydrogens. And you'll see the word amine in the name. An amide, on the other hand, also contains a carbonyl group that is bonded to a nitrogen. So you could have various groups on your nitrogen, and you will see the word amide in the name. So this is just a quick, brief overview of the different kinds of functional groups. So you'll be looking for these when you're trying to identify and classify the type of compound that is existing, and this will help you with your naming.